Okay, guys, this is it, the final project. So there's nothing really to learn with this. What I want to do is kind of walk you through the final project, and I strongly recommend that you come do this in person. But just so that if you need a reference, that's what I'm making this video for, is so that you can come back to it and refer to it. There's a lot of bells and whistles, a lot of pieces going into this project and the things you have available. Some things can help you. So understanding how it works can make the job a whole lot easier for you. So I'm going to walk you through that. Let's do that now. All right, guys, so this is where you'll be once you get to your final project. Remember, you'll access that off of the Modules tab. So that will be all the way down here at the bottom. And then you'll hit your final project. You'll load that up, and that will take you into the Smart Sparrow Simulator. Make sure that you're following all these instructions here. Watch the little video from Ariel Ambar, who's an ASU astrobiology professor. He's going to kind of give you an overview of what it is that you're doing. Once you've done that, go on to the instructions and read carefully what you're doing. Now, you have a scavenger hunt. So, as I say here, your main task is to find that habitable world. Most of your points come from that habitable world. As you lead to it, though, we want you to find a couple other things. We want you to find a terrestrial world. Okay, your habitable world is going to be terrestrial. We want you to find an ice giant, a gas giant, a red giant, a super giant, a main sequence star, things like that. You'll find almost all of these as you're looking for your alien world from that. But those are the things we want you to find. Now, when we're talking about data quality, this is how close your answers are to the actual answers. So you may calculate something, and if you're off by 5% or 10% or something like that, then your data quality is going to go down. You want your data quality to be as high as you can possibly get it. And we'll show you ways that you can help improve that. Assessments, this is, you've basically got some graduate students who are going to be working for you. You can pay them money, and after you teach them how to do the calculations, they will do all your calculations for you after that. Now, of course, that means you've got to give them enough examples that they understand what's going on. So I'm going to show you how that works. Here's your point breakdown. So you do have to find at least 30 stars. If you get bizarrely lucky and you find your habitable world in the first 10 stars, great. Have fun with that. But you still need 30 just to get full credit for the project. So that's, for most people, that's not going to happen. You're going to go through probably 200 or 300 before you find it. So you need to find a main sequence star, supergiant, red giant, white dwarf, and then from the planets, you'll need to find a gas giant, an ice giant, terrestrial world, and your habitable world. And as you can see, your habitable world is worth most of the points that are here. Your data quality is a percentage. 100% is the best, obviously. That means you've got it exactly right. You multiply that by 140 points, and so that will be almost half of your grade there, is how well you've done the math. And then your life form description is 40 points. The key thing I want to point out here is once you've moved on to the life form description, you cannot come back to the habitable world. So make sure that you are happy with your choice of the habitable world. Also, similarly, let's say you've run out of time. Don't let this happen to you. And you can't find your habitable world. You still haven't found it. Okay, choose the best candidate. Go with that, and then do your life form based on that best candidate that you found so far. There's no reason to give up those 40 points just because you haven't found your habitable world. But if you're starting early enough, if you've got 2 weeks to do this, it should be plenty of time. All right, so when you start off, it will populate the star field that looks like this. And you can see that I've already actually clicked on some of these. But whenever you click on a star and you do view star data, here's where you get your data. So it gives you the parallax and the peak wavelength. That should mean something to you, right? It tells you the star flux that we've got. Metallicity, you probably won't really be using much in this particular thing. It's information. It gives you an idea of how many planets there are in the system. So then it's going to ask you to calculate a bunch of things. So you're going to need to calculate the distance in light years, not in parsecs. Well, you know how to do that. You do that using the parallax. You're going to need to calculate the luminosity. You know how to do that too. You do that using the parallax and then the distance from the star, or the parallax and then the flux from the star. The temperature, you know how to do that from Wien's law. So you'll use this to get the temperature. The peak color, here you just choose, and this comes off of your worksheets, your reference sheets. So it's on the same page with the HR diagram. It's one of the ones you downloaded from the Getting Started module. You look at the peak wavelength, you go down the path, and say, okay, 1349 means that it is infrared, or whatever it happens to be. Then once you've found your luminosity and your temperature, you're going to use that to classify the star. And you do that, of course, using your HR diagram. And it will be one of these four. It'll either be a main sequence star, a red giant, a supergiant, or a white dwarf. If it is a red giant, supergiant, or white dwarf, call it that and then say, you're done. This star is dead to you. Move on to another star. Because if it's not a main sequence star, it is not going to have a habitable world. All right, let's assume for the moment that it actually is a main sequence star. If it's a main sequence star, then we're going to want you to calculate the mass, the radius, and the lifetime. Now, let me give you a tip here. This gives you some different units that you can use for the lifetime. Just leave it blank, and then it's in years. And so then all you need to do is type in the lifetime in years. It will automatically adjust this for you then. I would not choose any of these. Just leave it blank. All right. Once you've done that, then I'm going to have to move my camera out of the way here. If it's a main sequence star, then you can go to page 2. Page 2 allows you to look for planets. Now, when you do that, and I'll move this back over here for now, you're going to observe, we've got a spectrum here, and then you're going to see a light curve here. And we're going to observe this planet for a whole bunch of days. A good starter is maybe 1,000 days. And that sounds like a lot, but it's not. Remember, that's only about 3 years. So that's something that's out maybe about to Mars, a little past Mars. Hit play. Now, here's a tip that I'm going to give you. Remember that if there's a planet, this Doppler shift line will be moving back and forth. So let's zoom way in on it. You see that I zoom in and that line right there isn't moving? That means there is no planet. If it is moving, there is a planet. And so I've got to observe it long enough to see the dips in brightness that show up here. So here I would say, for this particular star, I would say, has planet? No. And you're done. There's nothing else that you can do for that. So let's choose a different star. Let's try this one. So again, I'll show you how that works in a minute. I would go back to page 1. I would need to do all of this data for it. If it comes out to be main sequence, then I will go to page 2. Move that back over there so I can get to page 2. Okay. And again, let's observe for 1,000 days and let's see if this one has a planet. I'm going to zoom in. Yeah, nope, not looking good for that. So again, this one has planet. Now, once you've found a bunch of planets, what I suggest you do is you work in spreadsheet mode. And so this is spreadsheet mode where you've got all your planets here. Put in 10 planets. And then if you want to go straight to that planet, then you can actually click on the little eye here and you can actually go directly to it. So here's one that I found that I said had a planet. So let's go look at its data. So we're on page 2 for this planet. I'm going to zoom back out a little bit. So let's observe for 1,000 days. And now you see the light curve is running. And now you see how that line has been shifted. Okay, so that means there is definitely a planet here. Now that planet may be too far away to do any good, but there's definitely a planet here. So what I've got to do is I've got to wait. When the Doppler shift line goes to all the way to the left and then comes back across to the right, or crosses the center here, then the planet is either, remember, in front of the star or behind the star. Well, I'm only going to dip when it's behind the star. So I'm going to have to just wait. You see how it's reached a maximum right there? I'm going to zoom in. Oops, not that much. You see how that's reached a maximum right there? So I already know the maximum. It leaves that little gray line, and now it's headed back towards the center here. So in order to get the Doppler shift, while I'm waiting for it to get there, I'm waiting for it to get back to the center. All you need to do is bring your shading up to that gray line and click, and it automatically fills in the Doppler shift for you. So isn't that nice? You don't have to count the tick marks or anything like that. You just click. Now it's not smart. Wherever you click, it's going to fill that in. So make sure that you are hovering directly on that gray line there, and that'll give you the Doppler shift. Now, it looks like, though, I'm going to run out of days before this one ever gets back to the center. Well, that means I'm going to have to observe for a longer period of time. And I might have to observe for 5,000 days or 10,000 days. It can take a long time to watch this go across. All right. But we know that it's got a planet. Once it's got a planet, then you should know how to, you look at the brightness drop. You see how I can hover over where the line is? Right now it's at 100%. Eventually there'll be a little drop here, but it may be too tiny for me to see. So I'm going to zoom in, and then you can click and drag to get back to the line. So I'm gonna zoom back in, zoom way in on this thing. And in order to see it, in order to see that drop, remember, it might go to 99.9%. It might be a tiny drop. So I might have to zoom way in. But once I get that tiny little V, that tiny little drop, I can hover underneath it, and that will give me the brightness drop. I do 100 minus that percentage, remember, is the brightness drop. So take the lowest brightness, 100 minus that, and that's going to get filled in right here. In order to get the orbital period, I need 2 of those drops. I must wait till I see 2 of those dips. Then I'll find the day. See here, it's telling you the day where you are on the light curve. So then I'll find the day on that for that dip. And then I'll find the next day, find the day on that, subtract the 2, and then that gives me the brightness drop, exactly like we did in class. All right. Once you've figured out the orbital period, you're going to remember to convert it to years. That'll give you the orbital radius, the distance from the planet to the star, all of those being the semi-major axis. All that means the same thing. I'm going to need to figure out the mass of the planet and the radius of the planet. You know how to do that. And from that, I'll get the density. Based on its density, I'll decide, is this a gas giant, an ice giant, or a terrestrial? If it's a gas giant or an ice giant, you're done. There's nothing else, because those are not going to be habitable worlds. If it is a terrestrial world, I'm going to move my camera again. If it is a terrestrial world, then you can come to page 3. And this is where you will look for that habitable world. So to do that, I'm going to need to match the spectrum. Now, this one, obviously, I haven't finished the data, so I've only got the blue line here. But there will normally be a blue line and a white line with dips in it. That's the absorption lines in the spectrum. So what I'll do, I can calculate the temperature. You guys know how to find the effective temperature. This equilibrium temperature means effective temperature. And then you'll choose these gases, and you choose them so that the white line and the blue line exactly match. You'll see that when you get one that actually has dips. You'll find that if I click CH4, for example, you'll look and see, does it match existing dips? If not, it's not there. If yes, then it is there. So I click it. And I'll go down to the next one. Maybe I'll check to see if there's CO2. Well, that one didn't match, so I'm going to uncheck that. Maybe I'll check to see if there's water. Sure enough, that one matched. So I'll keep that one there, and so on and so on. You see how that works? Once you've figured out which gases are present, remember, this is going to determine what any aliens are present in terms of what they're breathing. The computer will actually calculate the absorption percentage for you. You don't have to do that calculation. It'll say, 28% or whatever. You then look at your chart and you'll decide, is that none, weak, moderate, or strong greenhouse effect? And all it's doing there is, let's say we decided that it was moderate. It's going to depend upon whatever percentage you get here. It's going to add that to your equilibrium temperature, and that's what's going to be the surface temperature. The surface temperature, it'll tell you the pressure once you've done the work. It'll tell you the atmospheric pressure. You go into your water phase diagram and look at the phase of water. If it's solid or gas, it's not habitable. If it's liquid, you just found your habitable world. You win. Okay? That's how that works. Now, if there are any questions about that, be sure and come and see me. So that's the basic idea. But now I'm going to show you how you can automate things. So if we're on the assessment tab here, you'll start out with $50,000 that you can pay your graduate students with. And let's say, let me go back to page 1 here. Let's say that I don't want to calculate the parallax anymore. So if I find the star distance, let's say I calculate the star distance here for 10 stars, and then choose all 10 stars. You got to make sure that these 10 stars are exactly correct, because you're going to spend money for them. Then you can spend $125. If you've got all 10 of those correct, then your graduate students are like, I understand, we got it, boss, we'll do it from here on out. And you will never have to calculate the distance again. Anytime you click on a new star, it will automatically calculate the distance. Now I click the assess and, oh my gosh, I suck. Well, that's because I don't have any answers for any of these. So my percentage was 0%. So you need to have as close to 100% as you can for all of these. If it's within range, then it'll give you credit for it. Well, I just wasted $125. You don't get that back. So make sure that you've got it right. One of your top priorities should be to teach your graduate students to do all of this work for you. Anything that involves math, they can do for you. You'll have to show them how to do it 10 times, And then after that, they'll say, we got it, we'll move on. Now, you'll still have to do things like the peak color yourself, the classification you're going to have to do yourself, because your graduate students are like, oh, I don't want to have to think about that science stuff, man. I just do the math. All right. Same thing when we go to page 2. You'll be able to assess the brightness, the Doppler shift, the brightness drop, and the brightness drop period, in addition to these things here. You want to get these as soon as possible. The reason for that is then you won't have to wait for that dips to appear. It will just automatically give it to you. Your graduate students will do that work for you. So yeah, it's expensive. It's $2,500, but it's worth it. It's by far worth it. And you see that you only have to have 7 of them to teach them how to do this. Okay, so you'll find your 7 best and you'll do it from there. And again, it's worth it to go ahead and have them assess all of these for that. When you get to page 3, you'll see there's only one thing they can assess, an equilibrium temperature, which we've been calling the effective temperature. But there's a lot of calculations that go into that. Remember that you have to figure out the flux, you then figure out the flux of the planet, you figure out then the effective temperature based on that. So they will fill that in for you. All the rest of this stuff, like the game with the matching this, doing the spectroscopy to match the absorption spectrum, you're going to have to do that yourself. All right. Now I'm going to move the camera over here. Other things that you can assess then. One thing you can assess is the scavenger hunt. When I wouldn't do this until you think you found your habitable world. Once you think you've found your habitable world, you can spend $100 and it will update the scavenger hunt. Well, I haven't found anything yet, but it'll put a little check mark if you found it. You want to have all 8 of these checked before you're done. Now, don't keep obsessively hitting assess. Yeah, it's only $100, but you're eventually going to run out of money if you do that. And then you've got no way of knowing if you actually found your habitable world or not. So don't spend all your money. The last thing that you want to check is your data quality. And so you can assess that. It will update it. It costs you $100 to assess it. So I would not do this until you think you're ready to go. This is your page 1 quality, your page 2, and your page 3. So page 1, page 2, and page 3, and then your overall. You want this to be as close to 100% as you're happy with. Let's say that you've got something that sucks like I've got here, 20%. That's terrible. Okay, this is telling me that most of my problem is on the stars page here. Well, I haven't filled in the data. But this will give you an idea of where your problems are. Go back and fix the problems. You've got 2 things you can do. Go back and correct the numbers. You've got some problems in there somewhere. Go back and fix them. Alternatively, if this is not a star that has a habitable world, but it does have a planet. Well, let's say that you figured out that this planet is 50 AU from its star and it's a sun-like star. Okay, way too far away, way too cold. That's not your habitable world. There's no real point in wasting your time doing all the data for it. However, if you don't fill those in, it counts those blanks as zeros and your data quality is going to suck. So you can actually delete the star from the list, and then it doesn't count for you or against you. All right. Remember though, you don't want to delete too many of them. First of all, you have to have 30. But second of all, the more stars you have, the less each one counts. And so even if you do nothing to correct your old, the problems you have with the old stars, if you add in a whole bunch more stars and get all those right, then each star counts for less. If you only have 30 stars, then each star might count for, 5% or something like that. On the other hand, if you have 300 stars, now each one's counting 0.5%. So little mistakes don't cost you as much. If your graduate students are doing most of the work for you, that can be a viable strategy. So there's a game aspect to this. Don't spend all your money, but you do want to spend your money so that you can have your graduate students doing the work for you. All right, once you have found everything and you are sure you've checked your scavenger hunt and all of these are checked and you're happy with your data quality, because you can keep doing this until you've got 100% on this part. Then what you'll do is it'll be time to actually submit your data and you'll be ready to go. Now, I obviously don't have all of my data, so I can't save this. But when you do that, it'll take you to the next page. So because I'm the teacher, I can jump ahead. So I'm going to manually jump ahead to what the life form description is going to look like. All right. Now, it will fill in this data from your habitable world, from the world that you selected to be your habitable world. It should give you the numbers here. That said, I wouldn't trust it. Once you've found your habitable world, go to page 1 with all the data. Let me go back into here. So when you're in data mode and you're looking at the particular star, take a screenshot of this. Then go to page 2, take a screenshot of this. Then go to page 3, take a screenshot of this. That way you'll have all of the data that you need. Okay? All right, I'm going to go back to the alien life form description here. Once you've done that, you're going to do the same analysis that we did last week. You're going to figure out what is the body style, what is its respiration, what is its respiration energy. We're just doing negative, low, medium, or high. Activity level, locomotion, metabolic classification, carbon source, energy source, technology, climate, and dress. And then once you have all those set and you're sure of your answer, now you can hit submit. And of course, now it's not going to let me do it because I haven't done it yet, but then that will actually submit your score. Okay, and then you'll get to this final page here, and that means you've got it in there. Once you do that, you are committed. There is nothing I can do to change your answer. So make sure that you've got all the points that you're going to get from that, and then click finish, and you're done. Okay, so that's it. I strongly recommend that you do some of this in live help with me. Once you've kind of got the pattern, you've done a star or two, you're going to be fine. You're going to see all the details of how it'll go, and you'll just keep going. You're also welcome to work together. Everybody has the same picture, but when you click on a star, you get different data. So one person's habitable world is not going to be another person's habitable world. So it's perfectly fine for you guys to work together and help each other learn how to do it. This is where having a spreadsheet can be really handy. I mean, yes, once you've done 10 stars, your graduate students can do the work for you, but you want to make sure you've got those 10 stars exactly correct. So if you've got your spreadsheet set up, it's going to be really easy. You're going to get your 10 stars right away. Your graduate students are going to do most of the work for you, and you're just going to be chugging along. So it's worth doing. The last thing I want to caution you about is finish your project. You do have 2 weeks to do this, and that's enough, but not if you're waiting a week. If you've only got a week, you're probably not going to finish. And if you're waiting to the weekend before, you're doomed. Remember that this is 25% of your grade. I've seen it happen over and over and over. The students get busy with their other classes, they procrastinate on it, and they don't finish their project. You're not going to pass. That's just really what it comes down to. If you don't finish your final exam, you can't expect to pass the class. That's just how it is. In the worst case scenario, though, still go ahead and choose that habitable world and do the life form description. I mean, you may only get 100 points out of 300. A 33% on your final is better than a 0 on your final, because if you're close, that might be just enough to push you over into getting a C. It's going to be tough, but if you get started now, there is absolutely no reason why you can't get 100% on your final exam here, and that's going to give you a really good grade by the time you're done. As always, come by live help and let's work it out. We'll see you then.